Hello there, Mr. Sutton here, bringing you the 2023 Massachusetts MCAS solutions. On this problem, we're told that the area in square units of a rectangle is represented by this crazy expression, 6x squared plus 15x. We want to know another way of representing that area for the rectangle. So basically, we're just being asked to turn this into a different form. Now, looking at all the answer choices, we've got all these parentheses going on, so it looks like one way we might be able to change this up is to factor it. If we wanted to factor it, we might try taking out the greatest common factor. That's usually the first thing we do when we factor. So between the 6 and the 15, I can take a 3 out of both of those. Those are both divisible by 3. And we have an x squared and an x, so I can take an x out as well. So if I take 3x out of this, I'm basically dividing each of these things by 3x. 6x squared divided by 3x, well, 6 divided by 3 is 2. And x squared divided by x, that cancels out an x, so there's an x left over from that. And next, 15x divided by 3x is going to be 5x. Looking at my answer choices, it looks like we have the matching expression for this in choice A, so we're going to choose that one. On this problem, we're told that a circle graphed on a plane has a center at 2, -4 with a radius of 4, and we're being asked to give an equation for the circle. Now, they already kind of gave you the basic form here. They just wanted you to drag and drop some numbers into these boxes to make this all true. But it helps if we remember the general formula for the equation of a circle. That's going to be x minus h squared plus y minus k squared equals the radius squared, r squared. So this is telling us what to put into each of these boxes. H and k are the x and y value of the center of the circle. So for the h value here, since my center is 2, -4, I want 2 to go in there. And then for my k value, that's the y value of the center, this is already a -4, so let's put minus -4 there. And now finally, this last one, we got to be careful. Here they want the radius squared. But if we look closely at this, this is already being squared. So the radius squared, since the radius is 4, we would say 16 is the overall number that should go on this side of the equation. But again, they already squared it for us, so we just want to write 4 in here, not 16. If we wrote 16 in here, then we'd be squaring the 4 twice, and that wouldn't give us what they wanted. For this problem, we're given the square root of 6, and we're squaring that. We want to know what the value of the expression is. So just in general, square and square root undo each other. So canceling out those things, we should just end up with a 6. Now, another way to think about this, and that was choice A, another way to think about this is square root of 6 times itself would be the square root of 36, and the square root of 36 is still 6. For this problem, we have a line plot showing number of people attending a film showing at a new theater. So, or at least a new film at a movie theater. I don't know if the theater's new as well. Anyway, based on this, we want the median number of people who attended this showing. So when you have a line plot, to get the median, since everything is already arranged in order, we just have to cross off these different x's until we get to the middle number. So we'll cross them off 2 at a time. So we've got one of these and this very last one. Next we have this x and another one of these in this first column here. Now we've got one of these x's and this line, this one over here. Another x here and one of these 3. Another x here, another one of these 3. Now we move on to the next column from the left. We've got one of these x's and this x right here. Now we have another one from this column and one of these 2 x's. Another one from this column, another one of these, and at long last we have one x remaining, so that would be this one right here, and the number associated with that column is 127. So our median, our middle number, out of this whole thing, if we were to write all these out, is 127, so that means we've got choice B. For this problem, we want an expression that is equivalent to this one. So this is kind of the reverse of the first question where they gave you something and you had to factor it. This is already kind of factored and we have to multiply it back out. So the 14 initially is going to stay the same. We need to distribute this -2 to the parentheses. So we have -2x and then negative 2 times negative 4 is 8. And now that I've got rid of the parentheses, I can combine like terms. So that's going to be 14 plus 8 is 22. Cannot combine that with the negative 2x, so we'll just pick our answer choice that matches that, which is choice D. For this question, we have this grid here with this line drawn through 2 points, and we're going to use that for 4 parts of the question. Part A, we want to know the slope of this line. So in general, slope is rise over run. So just taking a look at kind of how we're getting from one point on the line to another point, it looks like we're going down 1 and right 2, down 1, right 2, and that's pretty consistent all the way across. So down 1, right 2, that means we're going to have a negative 1 divided by 2 for the slope. Another way to get this is you could use your slope formula on these 2 points and do like y2 minus y1 over x2 minus x1. 2 minus 5 would be negative 3. 2 minus negative 4 would be 6. Negative 3 over 6 would still give you negative 1/2. For this part of the question, they're telling us that line P, which they're not drawing, is parallel to line K, and the y-intercept of P is the point 0, negative 4. Based on that, we want to create an equation that represents line P. So let me start with a general form of a line. Now there's different forms of lines that we can use. There's point slope, there's slope intercept. Since they're already giving me the y-intercept here, I'm thinking that slope intercept is going to be the fastest way to come up with an equation. So that's the formula y equals mx plus b. So the way that you use this formula, m is our slope, b is our y-intercept. So you basically need to figure out the slope and the y-intercept, and then you can plug it right into this formula. Now the good news is we already figured out the slope in part A. We found that it was down 1, right 2, so negative 1/2. The b value we can also get pretty quickly. They said the y-intercept of this line that we're trying to get the equation for is 0, negative 4. So the b value is just the y value of that y-intercept. The x value of the y-intercept is always 0, so the only thing we're really changing is that y value. So we can say then that b is negative 4. And plugging all this in now, we have y equals negative 1/2 x minus 4, and this is our parallel lines equation. For part C, we're told about another line, line R, that goes through the points negative 2, 1, and 1, 0. And we want to know, based off of this, if line R is parallel to line K. One way you could do this would be to just graph these out. Negative 2, 1 is right here. 1, 0 is over here. And you could graph those out and kind of compare them. A more exact way to do it would be to actually find the slope of the line that goes through these points and compare it to the slope of the original line. And in general, we know that if lines are parallel, the slopes are going to be the same. So that's what we're looking at when we compare these. I'm going to go ahead and find the slope. So in general, my slope formula, we've got m equals y2 minus y1 over x2 minus x1. So for our y values, we're doing 0 minus 1 in the numerator. And in the denominator, we've got 1 minus negative 2, or 1 plus 2, as it were. So this comes out to negative 1 over positive 3. Now, comparing that to the slope of this original line, that slope was, remember, negative 1/2. That's not the same as negative 1 over 3. Since we have different slopes, we know for sure, without even having to eyeball this, that the lines are not parallel. For part D, we're given the same graph here, and we're told that another line, yet another one, is perpendicular to line K. And they're also giving us 1 point actually that line S passes through, 5, negative 2. So we want an equation for this other line. Okay, well, perpendicular. Perpendicular means that the slopes of the two lines will be opposite reciprocals. So if I know the slope of the original line, I can very quickly figure out the slope of the perpendicular line by essentially flipping it and changing the sign. So the old slope, remember, was negative 1 over 2. And now if I flip the fraction, take the reciprocal, and change the sign, now I have a positive 2 over 1, or just positive 2. So when I'm writing the equation of this new line, in general, we've got y equals mx plus b. So if I've got a slope of 2, then my line should be something in the format of y equals 2x plus b. We already know the slope. We do still need to find this b value, however. Now, one way you could do this is to plug in the x and y value that they gave us in for the x and the y in this equation right here. And then that will leave just a b value that we can solve for. So if I plug in -2 for y, I've got -2 equals, and I'll plug in 5 for the x, so 2 times 5 plus b. 2 times 5 is 10. And if I subtract 10 from both sides, I've got b equals -12. So putting that back into my y equals 2x plus b, I now have y equals 2x minus 12. And that is my perpendicular line. On this problem, we're given this inequality h, representing the number of hours that Emma has to work to earn at least $360 by the end of the month. We want to know, based off of this, the minimum number of hours Emma needs to work to earn that $360 by the month's end. Okay, so basically, if we solve for h, we'll get the answer that we're looking for. So I need to get h by itself. So following my rules of inequalities, one thing I want to do is subtract this 240 from both sides. Now, just like with equations, when you add or subtract with an inequality, nothing changes except the numbers themselves. Like, the inequality is still going to be the same direction if I just add or subtract a number from both sides. So subtracting 240 from both sides, 360 minus 240 gives us 120 over on the right side. We still have greater than or equals to here. And next, to get h truly by itself, I need to divide by 12. Now, if I'm dividing or multiplying by a positive number, that also preserves the direction of the inequality. It doesn't change the direction. It's only when I multiply or divide by a negative that this inequality is going to reverse. So just dividing by 12, I end up with h greater than or equal to 10. So this is telling me that the number of hours must be 10 or more, so at least 10. Which means that the answer choice I'm looking for is choice B. That's the minimum number of hours that Emma could work. For this problem, we are given a line segment, FG, and they want us to put a point E on here somewhere so that the length of EF is 3 times the length of EG. So basically, we want to put a point on here somewhere so that the distance from the point to F is 3 times the distance from that point to G. So if we want the distance from the point to F to be bigger, we want the point to be more in this direction. Now, counting up here, just diagonals, I've got 1, 2, 3, 4, 5, 6, 7, 8 of these diagonal segments that it takes to get from one point to another. So if I put a point right here, that would give me 6 diagonals this way versus 2 going the other direction. And that would make this 3 times as long as this, since we have a consistent slope going on here. So that's where I'm going to put point E, and I'm going to call it a day on this one. On this problem, we're just trying to find the solutions of this equation. Now, normally, with one of these quadratic equations, you would have to factor it first, but they've already done that for you. So if you're at this point in the problem, you really only have one more step, which is to set each of these factors individually equal to 0 and solve each of those mini equations. So we can write x minus 5 equals 0, or x plus 7 equals 0. Because if I zero out one of these factors, 0 times whatever the other factor is going to give us a result of 0. So looking at my first equation, to solve for x, I have to add 5 to both sides. So we have x equals 5. And over here, I need to subtract 7, so x equals -7. So I'm looking for the answer choice that has positive 5 and -7, and that is answer choice C. For this one, we have a right triangle with a few measurements, and we're trying to figure out, based on the diagram, how long side R is right here. So one thing to notice here is that we have a 60 and a 90-degree angle in this triangle. That means we only have 30 degrees left for that other side, which makes this a 30, 60, 90 right triangle. And on the formula sheet, there's a ratio for the sides of a 30, 60, 90 triangle. Here it is again. We've got an s radical 3, and 2s, although the letters might be different on the formula sheet. It's the same idea, whatever letter you want to use. So when I'm doing these problems, I like to just label each side of the triangle with one of these expressions here, just so I know what I'm looking at. So the side across from the 30 degrees is going to be my s side. So that's this side right here. The side across from 60 is my s radical 3. So here's 60, here's the side across from that, s radical 3. And that's not actually involved in the problem, but I'll put it on there anyway. And then the side across from 90, the right angle, is the 2s side of one of these. So to figure out anything off of this, you just need to take the side that they actually gave you measurements for, 10 in this case, and set it equal to the s expression that's next to it. So we can say that 2s is equivalent to 10. Well, if 2s is 10, then to get s by itself, I just have to divide by 2. So I have s equals 5. And if I'm looking for the length of side r, let me see what s expression that is. Oh, look at that. R is s. Well, that's a happy coincidence. So if r equals s, then that means r also must equal 5. So that gives us choice A, 5 centimeters. This question is a two-parter dealing with relationships between rational and irrational numbers. On the first part, they're just kind of helping us review some of the rules for how these numbers interact with each other, and they're asking us which of these statements is not true. So that means 3 of these will be true. Okay, let's go through them and see what we can eliminate. So choice A, the sum of 2 rational numbers is rational. Now remember, rational means the number can be expressed as a fraction. So it could be a whole number, an integer, or actually a fraction, any of those. If we add 2 things that are whole numbers or fractions together, or a mixture, we're going to get another integer or fraction by adding 2 fractions. We just come up with a common denominator and add them together. So this is a true statement. If you add 2 rational numbers, you get another rational number. Next one, the product of 2 rational numbers is rational. Well, if you multiply whole numbers or fractions or integers and integers and fractions, any of those, you're going to end up with something that is either an integer or a fraction. Multiplying 2 fractions together, we just multiply straight across, and we end up with another fraction. So this is also a true statement. Multiplying integers and fractions produces more of the same. So it's going to be C or D now that it's down to. So for C, the sum of a rational and an irrational number is rational. Well, one way that we can kind of reason about this is to come up with a counterexample. Let's see if we can prove this one false. Is there a rational and an irrational number that I could add together? There are. There's lots of them, actually. Let's pick 2 for my rational number. And for the irrational number, I could pick a lot of things. I'm going to pick the square root of 2. That's a crazy decimal that goes forever with no pattern. So if I add 2 and the square root of 2 together, I'm going to end up with something that is not rational. I'm going to end up with 2-point crazy decimal that goes forever and doesn't repeat. So this is a false statement. Adding a rational and an irrational number together is not necessarily going to give me a rational number. It's probably going to give me an irrational one. And instead of 2, you also could have used pi, but then you'd have to know that pi was irrational. So I'm thinking it's going to be choice C. Just to double check, though, let me also look at choice D, just to be sure. And here they're saying the product of a non-zero rational number and an irrational number is irrational. So for example, 2 times the square root of 2. Well, 2 times a crazy decimal that goes forever without repeating is going to give me another crazy decimal that goes forever without repeating. It's just going to be double the last one. So this is going to be true. 2 times the square root of 2 is also irrational. Or if you used pi, 2 times pi is also irrational. So then choice C is what we're looking at. So for part B on this question, we're given the expression 2 minus 6 radical 25 over radical 4. And we're asked if this whole thing is going to come out to something that's rational or irrational. Now remember, rational means we can express the whole thing as a fraction without any crazy radicals left over. No decimals that go forever without repeating. So one thing I'm going to do here is I'm actually going to simplify this a little bit. so that let's see if I can get rid of these square roots. The square root of 25 is actually rational. The square root of 25 is just 5. So we have 2 minus 6 times 5. And then I also know the square root of 4. That is just 2. So this is really what I'm looking at. And if I wanted to go even further, I could do 2 minus 30, which is negative 28. And negative 28 divided by 2 is negative 14. So I could actually simplify this to an integer, let alone a fraction. Based off of all this, the value of the expression must be rational. Because, now we have to pick up because here, and we can't just say because it can be expressed as a fraction. That's not going to be good enough. So we have all the terms are rational, one of the terms is irrational, all the terms are irrational. Well, I think we can agree that not all the terms are irrational. 2 definitely isn't. And if we look at these square roots, so the square root of 25 is not irrational. Since 25 was a perfect square, that turned out to be the rational number 5. The square root of 4 was the rational number 2. So everything in here, after you simplify it, is actually rational. So if all the terms are rational, and you're putting them in a fraction, you end up with something that is also rational. So that's going to be all the terms are rational. For this problem, we're given a line on a graph, and we want to know which equation best represents that line. All of these equations are in y equals mx plus b form, slope-intercept form. So just looking at the graph, if we can figure out the slope, the m value, and the y-intercept, the b value, we can quickly figure out which one of these equations goes with this line. So looking at my graph, my slope, what am I going up? What am I going over? So I'm going to just pick this spot that's right on the y-axis. I didn't have to, but I got to start somewhere. So to get from here to the next easy place to read on the line, I have to go up 2 and right 3. So up 2, right 3, it's rise over run. That gives me an m value, a slope of 2 over 3. Now for my y-intercept, where our line is going through the y value negative 2. So our y-intercept is negative 2. So that's our b value then. Putting it all together then, we can write y equals the m value of 2/3. We have an x there still. And then b value is negative 2, so minus 2. And that is matching up with answer choice A. For this problem, we've got a 4-parter, and here's the stem of it all. The price of a ticket at a theater is X dollars. The manager of the ticket uses the function t of x equals 100x minus 4x squared to predict t of x, the total ticket sales in dollars. So basically, you tell me the price of a ticket, and this function is supposed to tell us how much money we're going to get from selling those tickets. And it is interesting to note that this is a nonlinear function. This is something that's got an x squared in it. It's a quadratic. So anyway, here's part A. What are the predicted total sales in dollars when the price is $10? Okay, so they're giving us the price. To get the total sales, we just have to plug that price into the t function, so t of 10. So we've got 100 times 10. We're replacing all the x's in here with 10s. Minus 4 times 10 squared. Now this is the no calculator section, so we're going to have to do all of this arithmetic without the aid of a calculator. So let's use our friend PEMDAS here. We'll do the exponents first before doing anything else. So we've got 100 squared happens before this multiplication by 4. So 100 squared, that's 100 times 100, or I'm sorry, 10 squared is 10 times 10, which is 100. So we've got 4 times 100. Now we have to do the multiplying before we do the subtracting. So we've got 100 times 10, which is 1,000. And 4 times 100 is 400, and it's negative. And then finally, 1,000 minus 400 tells us that we have ticket sales of $600. For part B of this question, we want to know the increase or decrease in predicted sales when the price of tickets is increased from $10 to $12, and explain how we got our answer. Now, because this is not a linear function, we can't assume that it's going to be an increase. This actually looks like a parabola when you graph it. So for all we know, we might be going back down as we increase the price. We don't know. So first thing to keep in mind is we already found the ticket, the sales from $10 in part A. That was, again, $600. So our strategy on this one is we're going to figure out the sales from $12 tickets and then compare that to the $600 that $10 tickets gave us. So for 12, we're going to plug that into our t function. So that's going to be 100 times 12 minus 4 times 12 squared. And again, no calculator, so we do this out by hand. 12 squared is 144. And then the multiplication comes next. 100 times 12 is 1,200. And then 4 times 144, well, let me think here. You could do long multiplication, and that's fine. I'm just trying to do this in my head. I know that 4 times 150 would be 600. So this is subtracting 4 times 6 from that. So 600 minus 24 would be 576. And now I'm doing 1,200 minus 576. So let me think. 1,200 minus 600 would be 600, and then 600 minus 576, that would be 24. So 624 overall is what we would have there. Now comparing this to my $10 price, if I do 624, the new price, minus the old price of 600, I see that there's a difference there of $24. Since my price went up as I went from $10 to $12 tickets, that means we have an increase in $24 in ticket sales. For Part C, we're asking for the ticket price in dollars that results in the maximum value for predicted sales, and they want to know how we got the answer. One way you could try this is plugging in a bunch of values and seeing what that looks like. Unfortunately, you wouldn't be guaranteed you plugged in the exact value that gave you the maximum. It might be a whole dollar amount, it might be like a certain number of dollars in 25 or 50 cents, or even something in between. So we need something a little bit more rigorous to get the maximum. What's going to help us here is that we know this is a parabola. It's a quadratic. And we know that the maximum value on a quadratic happens where that thing turns around, happens at the vertex. So if we can figure out where the vertex of this parabola is, that will tell us where the maximum value is. All right, well, we have a formula for dealing with things that are in standard form for finding the vertex. So I'm going to first put this in standard form. I'm going to rewrite this as negative 4x squared plus 100x. I'm just putting the squared thing first. And now I can think about this as something in the form of a squared or ax squared plus bx plus c. So there's a formula for finding the x value of the vertex. I call it the vertex formula. In any case, it's the x value of the vertex equals negative b over 2a. So basically, you take negative the coefficient of x and divide it by 2 times the coefficient of x squared. And this always gives us the x value of the vertex. So this is going to be negative 100 over 2 times negative 4. So that's negative 100 over negative 8. And dividing that, well, let me think here. I don't know what 100 divided by 8 is. However, I know that 8 goes into 96 12 times. I've got another 4 to get to 100, so that's 12 and a half, or $12.50. So that's the value for tickets that would give us the most sales. For the final boss battle on this question, they want the maximum value in dollars for the predicted sales, and then show or explain how we got it. So now the good news is we know the maximum, the maximizing price for tickets that will give us the maximum value for sales. We found that in Part C. Remember, that was $12.50. So if we know the max happens when x equals 12.5, we can just plug 12.5 into the t function in order to figure out what the maximum actual value of sales is. So we're doing t of 12.5. That's 100 times 12.5 minus 4 times 12.5 squared. And here's where we are really wishing we had a calculator. This is not going to be fun without a calculator, but we do have some tools that we can use to figure it out and fully simplify this. Because I'm guessing we don't want to just leave the amount like this and put a dollar sign next to it and say, hey, I'm done. It's the MCAS, not the AP calculus exam. So you have to simplify your answers to some extent. So I'm pretty sure I can do 100 times 12.5 without a calculator. This 12.5 squared is going to be kind of annoying. So I could use long multiplication to multiply that out, but here's another little trick you could use if you don't feel like using long multiplication and then moving the decimal 2 places at the very end. So I'm going to think of 12.5 as 12 plus 0.5, and I'm going to multiply that by itself. So I've got 12 plus 0.5 times 12 plus 0.5. And now I'm just going to lobster claw FOIL this thing out. 12 times 12 is 144. 12 times 0.5 is 6. 0.5 times 12 is also 6, so we have 2 of those. And then 0.5 times 0.5, I need a little decimal multiplication here. That's going to be, well, 5 times 5 would be 25, and then there's 2 decimal places there that I have to move that, so 0.25. So adding all this up, we've got 144 plus 6 is 150, plus another 6 is 156, plus 0.25 is 156.25. Great. So going back here now, we've got 100 times 12.5 minus 4 times 156.25. Still got some math to do. I'm pretty sure, again, I can deal with this 100 times 12.5 pretty quickly, but this 4 times 156.25, that's kind of annoying. So what I'm going to do on this one is I'm going to do a little bit more algebra, arithmetic kind of stuff. I'm going to treat this as 4 times 100 plus 50 plus 6 plus 0.25. I'm basically going to split this up into place values here. And I kind of double dipped with the decimal. I'm just going to treat that whole 0.25 all at once. So 4 times 100 distributing here, that would be 400. 4 times 50 is 200. 4 times 6 is 24. And 4 times 0.25 is that's a quarter of 4, that's 1. So we got 400 plus 200 is 600. Another 24 gives us 624, plus another 1, 625. So going back through here, we have 100 times 12.5. Just move the decimal twice because there's 2 zeros. So that's 1,250. Minus, we just figured out that this was 625. And if we subtract that, let's see here, that's going to be another 625. Well, that's interesting. So $625 is the most sales we're ever going to get for this theater here. On this problem, which is a two-parter, we're given 2 functions, an f function and a g function. The f function, they gave us the graph, and the g function, they gave us a table of values. So for this first part, they have some statements about f and x, and we have to figure out which one is true. Now, if you look at all these different answer choices, they're all talking about comparing the minimum value of f and the maximum value of g. So it would probably be a good idea to figure out what those values actually are, and then we'll be able to pick one of these answers. So let's look at f first, the graph. The minimum value, the lowest y value that this thing reaches, if we just look at the graph, it's right here at the vertex, the turnaround spot. We're right on the x-axis here. So the f min is going to just be 0. Now for the g function, this is a little trickier because we don't have the picture to work with. But looking at our table of values, looking at our y values, we see that we're at -7, then -4, then -3, and then it turns around and we get those symmetrical values of -4, -7, and presumably there's a -12 over here. Presumably if we went back to, I would say, like -6, I bet that would also be a -12. Because all these values are symmetrical, at least the first 5 are, that tells us that this middle value at the center of all of them must be where the vertex is. That's the only way you're going to get this symmetry, is if this is the vertex. So that means, and they told us it was a quadratic function, so we know it's not some other weird random function. So that means that the maximum or minimum value is going to happen at this table entry with 0, -3. That maximum value, and we know it's actually going to be a maximum value for this one, because you'll notice that as we move from left to right in these table values, our values are going up and then they're going back down. So this -3 is the highest y value this thing ever reaches. So we have an f max, or g max rather, of -3. Comparing these, we see that 0, the f min, is greater than -3, the G max. So we have to look for the answer choice that says that. Let's see, choice A, minimum of f is equal, nope. Choice B, maximum value is less than, minimum value of f is less than max of g. That's also the exact opposite of what happened here. And then choice C, minimum of f is greater than max of g. That is what we're looking for, choice C. Just looking at D to be on the safe side, they're saying here the minimum and maximum can't be compared. They actually can, because we can tell for certain what the min and max are for both of these. So choice C. For part B of this problem, they're giving us 3 statements about the 2 different functions. They're still comparing them, and now they want to know which of these statements is true or false. So looking at my statements, we have one talking about the directions that they're opening, another about the domain and the range. I'm going to make a little table where I compare them on all of these different attributes, and then I can choose true or false based off of my little table. So here's my table. I've got a column for f and for g, and we have rows for which way they open, the domain, and the range. So which way do they open? Well, f, that's pretty easy to see. We've got a picture. It opens up. G, we talked about this on the last problem. Looking at these values, my y values are going up, and then they're going back down. So that tells me that we're opening down for the g function. That's an upside down parabola. Now for the domain, that's the x values that are on the graph that I can plug in and get a real number back. Since this is a quadratic, it goes to the left and to the right forever, with no gaps in between anywhere. It's continuous. So our domain for both of these is going to be all real numbers, which I'll show with this little r here. And now for the range, that's the y values that I can get back. Looking at my f graph here, it looks like I can get all the y values up to positive infinity and all the way down to 0. We can't get anything lower than 0. So I'm going to say my range then is going to be y greater than or equal to 0. Now for the g function, we found out on the last problem that the maximum value of the g function was this -3. It doesn't get any higher than -3. So here, I'm going to say y is going to be less than or equal to -3. That's the highest we can get. With all that in mind, let's go ahead and look at our true-false statements. So statement 1, the graphs of the functions open in opposite directions. Well, up versus down, so that is true. They're opposite directions. This one now, the functions have the same domain. They do. They both have the domain of real numbers. So that is also a true statement. All right, let's go for 3 in a row. The functions have the same range. That is not true. The f function goes up forever. The g function goes down forever. So that's, but they don't go both directions, each of them. So that's definitely very different ranges. So that is a false statement. For this problem, we have a student folding a piece of paper in half repeatedly, and we have a table showing the number of layers of paper for each of the first 4 folds the student makes. So here's our table. Based on the pattern, we want an equation showing the relationship between x, the number of folds, and y, the number of layers of paper. Now there's a short and a long way to do this question. The short way is look at this pattern and realize that we're multiplying by 2 over and over and over again to get the next thing in the pattern, which kind of makes sense because if you're folding a piece of paper in half, then you end up with twice as many layers each time you do that. So repeated multiplication by 2, that is an exponential function. That is choice D, where you have the variable in the exponent. So that's the fast way to do it, is sort of recognize this pattern and know it's exponential. If you didn't remember that, you could still get by on this one by plugging in some table values to these different functions and using process of elimination. For example, let's use the first function here. If I plug in the y value 2 from this first entry, that should give me 2 times 1 for the x value. Does that actually work? It does. 2 is 2 times 1. But that doesn't mean that choice A is the answer. We have to test out the other values. How about if I plug in 4 for y and 2 for x? Well, 2 times 2 would give me 4, so that actually also works. So we're feeling pretty good about choice A. However, if we plug in 8 for y and 3 for x, 2 times 3 does not equal 8. So that would mean choice A is actually bogus. The pattern falls apart after 3 rounds there. I'm taking a look at choice B. Is 2 equal to 2 divided by 1? It is. Is 4 equal to 2 divided by 2? Nope, 4 doesn't equal 1. So we can eliminate choice B based on that. Now choice C, if I have 2, does that equal 1 squared? Not so much. 2 does not equal 1. So that one we can eliminate after just one try. And then you can prove choice D if you wanted to by plugging all these things in. So 2 equals 2 to the first power. That is a true statement. 4 equals 2 squared. 8 equals 2 to the third power. And 16 equals 2 to the fourth power. So we can verify it that way and pick choice D. For this one, we have a librarian purchasing books and e-readers for a school library. We've got a certain number of books, and here's the average amount per book, $189.20. Let's see, and then the school, we've got 18 e-readers. Each e-reader is $54.90. We want the closest to the total amount the librarian spent on all of this stuff. Okay, so basic idea here is we need to multiply the number of books times the average price per book. We need to multiply the number of e-readers times the price per e-reader. That'll give us the totals for each. And then we need to add all of that together. The only catch is this is the no calculator section. So we need to estimate it. And if you look at the answer choices, these are nice round numbers. So let's estimate each of these things. So 11, that's pretty close to 10. So I'm going to do 10 for the number of books. And this $189.20, I'm just going to round that up to 200. I'm not sure how closely I need to round these things, but looking at these answer choices, I mean, these are pretty far apart. So I'm thinking I can be kind of loose with my rounding, and it'll still turn out okay. So 200 for the price per book. Now for the number of e-readers, 18, I'm going to round that up to 20. That's pretty close to 20. So I'm adding this next total now. I've got plus these two things multiplied together. So plus 20 times, and then the price of each e-reader, $54.90. I'm thinking 50 is close enough to that. I mean, I rounded up on the number of e-readers, so if I round down on the price, split the difference, that should actually work out pretty well. Okay, so multiplying this out, 10 times 200 is 2,000. 20 times 500, let's see, 2 times 5 is 10. Throw 2 more zeros in there. That's another $1,000. 2,000 plus 1,000 adds up to 3,000, which is one of the answer choices. So we'll go with choice C. For this one, we have an equation that they're saying is graphed on a coordinate plane. They didn't give us the graph, but they gave us the equation. And they want to know which of these ordered pairs represents a solution. So one way you could do this is to actually graph this out, rearrange it, put it in y equals mx plus b form. And if you've got some spare graph paper, you could do that and see which of these points appear to be on it. They said there are 2 correct answers, so I guess you would just pick the closest 2 points and hope for the best. Another way you could do this and be sure about your answer, if a point is a solution to an equation, that means when I plug in the x and the y value of the point, it makes the equation come out the same on both sides, come out true. So we actually could just plug these 5 points into this equation and see which ones work. So that's how I'm going to approach this one. So for this first one, we've got the x value -1, the y value 2. So I've got 2 times -1 plus 3 times 2, and I'm asking, does that equal 8? 2 times -1 is -2. This is going to be a plus 6 here. -2 plus 6 is giving me 4, which does not equal 8, so that's a no. We move on to the next one. We've got 2 times 0 plus 3 times 8 equals 8, question mark. 2 times 0 is just 0. 3 times 8 is 24. 24 obviously does not equal 8, so that's another no. For the next one, now we have 2 times 2 plus 3 times 1. Does that equal 8? Well, this is 4 plus 3, which is 7, not 8. Still no. So by process of elimination, if they said select the 2 correct answers, we kind of know what to expect from D and E, but just to be on the safe side, let me go ahead and test those. This will at least tell me if I made a mistake earlier on. So we've got 2 times 4 plus 3 times 0. 2 times 4 is 8. 3 times 0 is gone. So we have 8 does equal 8. So that is a yes. That's one of our answers. And then we have 2 times 7 plus 3 times negative 2. 2 times 7 is 14. 3 times negative 2 is negative 6. 14 plus negative 6 is 8. So that's also a yes. So we've got confirmation here. D and E are the answers we need to pick. On this two-part problem, we have 2 boards leaning against opposite sides of a wall, and each of the boards touches the ground a distance of 6 feet away from the wall, and they've also got some angles that we somehow measured to see what the angle was between the board and the wall. So first part, we want the length in feet of this board A right here. Now the key here is recognizing that board A forms a triangle with the wall, and it's not just any triangle, it's a right triangle, and it's not just any right triangle. Since we have 30 degrees here and 90 here, that means we have another 60 over here, so this is a 30, 60, 90 right triangle, which means that we can use that ratio that all of those 30, 60, 90s have. That would be S, S radical 3, and 2S, or whatever letters you want to use for those. So I'm going to go ahead and label my triangle now with these 3 sides. S is always across from my 30-degree side, so that's this side here, this 6-foot side. S root 3 is the 60-degree side, so that's the wall. And then 2S is always the hypotenuse across from the right angle, so that's up here. Ultimately, I want to find the length of board A, so I need to know what this 2S is. To know that, I need to figure out what just 1S equals. Now we see here that S is next to the 6 side, so that means that S is 6. And then board A, the length there is going to be 2 times S, so that's 2 times 6, which means that board is going to be 12 feet. For the part B of this problem, predictably, they want us to find the length of board B. I guess that makes sense. This one's a little bit trickier because this is not a 30, 60, 90 triangle. It is a right triangle, though, so you can still use some formulas. The one that's going to help us here is our SOHCAHTOA formulas, sine, cosine, and tangent, those ratios. So I'm just going to write out SOHCAHTOA just so I have kind of all of them at once at my disposal. Now, taking a look at my angle, the side that I have and the side that I want, they're giving me the side that's opposite from the angle that I know. And they also want the side that's the hypotenuse. So if I have opposite and hypotenuse, that's OH, that's the SO part of this, that's going to be my sine ratio. Sine of theta equals opposite over hypotenuse. Plug in some things in, I've got sine of my angle, sine of 35, equals the opposite side was 6, and I'm going to represent my hypotenuse with B. Now I have to solve for B. You might be freaking out a little bit because you're like, well, I don't know what the sine of 35 is, and I don't either. However, this is not a calculator question. They don't expect you to know that. All the answer choices already have either a sine or cosine of 35 built into them. At this point, you could just eliminate everything that doesn't have a cosine in it. So let's go ahead now and just get B by itself, and hopefully that'll give us one of these expressions. So to get B by itself, I would first like to get it out of the denominator. One way to do that would be multiply B by both sides. So I could write B times the sine of 35 equals 6. And now to get B truly by itself, I just have to divide by the sine of 35, which is all just one big number there. So I end up with B equals 6 divided by sine of 35. Now again, I don't know what this actually comes out to decimal-wise, but it is one of my answer choices. 6 over sine of 35 is choice C. On this one, we have a statement that a student correctly solved this equation, and here's the steps down below. Basic idea is they just want us to identify the property that was used for each of these steps. So this is one where you got to know your properties of equality and all that kind of stuff. All right, so let's see. Our first step. It looks like the only change here was that we reversed the order of the 1 and the 2x. So basically changing the order of addition. When you change the order of addition or multiplication, that is our commutative property. Now, the next one here, it looks like we've distributed the 3 to the 2x and the positive 1. That would make sense. You want to simplify one side of an equation before you start moving anything around. So that would be then the distributive property right there. For the next one, it looks like they subtracted 3 from both sides to get rid of this 3 and get a 1 on the other side. So that's our subtraction property of equality. That kind of straightforward there. And then the last one, we had to divide by 6 to get x by itself. So that's the only one that's left, the division property of equality. For this problem, they're giving us a triangle with some measurements. We have an angle of 40 degrees and these two x angles that are both the same, but we don't know what they are. We'd like to find out what they are. That's the point of this problem. So this all hinges on knowing that a triangle has 180 degrees for the sum of all its angles, its interior angles at least. So we can say that 40 plus x should add up to 180. Now since these x's are both the same, we can write 2x plus 40 equals 180. And that means if I subtract 40 from both sides, I've got 2x equals 140. And then dividing by 2, we have x equals 70 degrees. On this one, we have a system of equations. We have a parabola here for this first equation, and this other one's a line. We want to know the solution to this system of equations. Now, they did help us out. They told us that the system of equations has one solution, which is good to know because if you have a line, it might cross a parabola in 2 spots instead of 1, but we're just crossing at the 1 spot. And we need to find that point that crosses for both of these. So if we're solving this without just plugging in answer choices to both equations, we can use the substitution method. These both equal y, so that means I can replace one of these y's with the expression from the other equation. So what I ended up doing is I swapped out this y right here for the x squared minus 3. And this is a quadratic equation. So to solve this, I'm just going to get everything on one side, and hopefully I can factor it. So if I move everything over to the left side, I've still got an x squared over there. And now I can subtract the 2x to get it over to the left side. And I also want to add the 4 to get it over here. I've already got a negative 3, though. So negative 3 plus 4 is going to give me positive 1. And then there shouldn't be anything left on the other side, so I've got an equals 0 over there. So I've zeroed everything out. I've combined like terms. I've got it all in one side. It's even in standard form. I did all the things. So now I just have to factor the stuff on the left and go from there. So I have an a value of 1 right here. This is a 1x squared situation. So the easiest way to do this is just going to be to ask what two numbers multiply to positive 1 and add up to negative 2. Well, they're the same sign because it multiplies to a positive. It has to be either both negative or both positive. Since they add up to a negative, I know the numbers are both negative then. So negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. So that means I've got x minus 1 and x minus 1. Or I could just write that as x minus 1 quantity squared equals 0. Now just setting this equal to 0 to solve for x, if I plug in the x value 1, that's going to zero this out. So we have x equals 1 then for the x value. There's only one answer choice that has that. That would be choice C. But just to be on the safe side, let me plug that back in to at least one of these equations. I'm going to go with the linear one because that one's a little bit less intense. So I've got 2 times 1 minus 4 equals y. 2 times 1 is 2. 2 minus 4 is negative 2. So y equals negative 2. That gives me the point then 1 comma negative 2, which is actually, yes, choice C.